Welcome back to Data Maths Concepts. Today, what we're looking at is the January 2020 paper 2. We're looking at question 5. It is the statistics questions. As a group of 100 students estimated the mass M in grams of seeds. The cumulative frequency curve below shows the result. So this is a cumulative frequency curve that we're dealing with. All right, there it is. That's our cumulative frequency curve. All right, so we have the number of students on the y-axis and the mass of seeds in grams on the x-axis. Let us see what the first question is. The first question says using the cumulative frequency curve, all right? Actually, what we'll call Q2, which is 50% of the sample. So if we can find where the 50% margin is of the sample, we will utilize that number to pick up the median, all right? Because the median is always the middle, so it's 50%. So let's see what we have. We're looking at this number at the top. It is very important to look at the number here. This is the total number here. So it's 100. So 50% of 100 is at 50. All right. So what we're going to do though is at that 50, we're going to come across from 50. So we'll go across at 50 right there. Pick a line, go across at 50. And exactly where it touches the curve at 50, we're going to read down. So it touches the curve right here, right there. So we're going to take down our value there and then read off. All right. So let's see what this value is here. We want to read off this. Right. So in reading off, I'm seeing this as a 3.2 here. All right. So this value here is 3.2. All right. Because if you follow the scale, 3.2, 3.4, 3.6, 3.8, and then 4. So this value right here is actually 3.2. All right. So that is the median right there. So the median we got is 3.2. So let us mark that off, that our median mass is 3.2 grams. So we want to make sure we have that down. All right, let's get to the next question. It says the upper quartile. All right, so in context, we want to understand that the upper quartile is 75% of your sample. So the 75% of the sample. So 75% of 100 is just going to give us back 75. So that's the marker. That's not the answer. This is the marker. So what we're going to do is to 75% would be exactly halfway between 70 and 80. So we're looking at that line right there. All right. All right. Really on that line, so I'll fix it. This right there. I'm getting it coming down right there. All right, that's it. That's where I'm getting it. All right. So my 7 of 5, as you could see, was halfway between the 70 and the 80, which was right here. That was a 75. And then this was where it came down right here between 4.2 and 4.4. So the exact value that I'm getting down the bottom is actually 4.3. It's coming down between 4.2 and 4.4. So I'm getting 4.3 grams right there. So the upper quartile is 4.3 grams, right? So I'm getting the upper quartile. I'll call it Q3. So I'm calling it Q3. That's my upper quartile. And this is equal to 4.3 grams. So we have to just observe carefully and look at what we're dealing with. All right. All right. So we have those coming up. All right, let's go further. The next question says the semi-interquartile range. Now, what is the semi-interquartile range? The semi-interquartile range would have come from the interquartile range first. So the interquartile range, I'll just say that the interquartile range the interquartile range. And the word range will help us to understand that it's the biggest quartile minus the smallest quartile. So this is the interquartile range. So if I'm going to go semi would mean half. So I'm going to go Q3 minus Q1 over 2. So that's where we're heading. Definitely we have Q3 already waiting, but I definitely need to go and find my Q1 and then we put it all together. So let's go back to our graph in an effort to find what Q1 is. So let's go. Q1 is 25% of our sample, right? So 25% of 100 is just going to be 25. So 25 is going to be halfway between 20 and 30. Halfway between 20 and 30, 25 is going to be exactly halfway there. I could bring it down a little bit more, like somewhere there. Yes, right there. So that's my halfway between that. So halfway between that, though, is hitting me here. All right, so I'm getting it in the empty space again. So let me mark my spot right here. Getting it right there. So I'm gonna come down in an empty spot. There. So I'm seeing it right there. And it came down between 2.2 and 2.4. So I'm getting a 2.3. So for me, it came down at 2.3 right there. So let's mark off our 2.3 right there. All right, so it came down at 2.3 for that. And if you are wondering, this is our 25 right there. All right, let's go. So 2.3. So in an effort to find this, I just found out. So let's write down my Q1. Q1, I got 2.3 grams. My Q3, I already got 4.3 grams. So the semi-interquartile range is to say 4.3 minus 2.3, and then we divide that by 2. 4.3 minus 2.3 is 2, divided by 2. The semi-interquartile range is 1. All right, so there it is. The semi-interquartile range is 1 gram. All right, so that would have been the solution there for that. 1 gram. All right. Next question says, we want to determine the number of students whose estimate is 2.8 grams or less. Okay, so we want to find the estimate of some students with a gram of 2.8 or less. So let's just go to our cumulative frequency curve again. And here we're going to, all right, so let's go with our 2.8. Now, based on our reading, 2.8 is right here. 2.8, so 2, 2.2, 2.4, 2.6, 2.8 is right here at this marker. That marker before you reach 3 is 2.8. And then we want to make sure that this line that you draw here, this line that you're drawing here, you want to make sure that it just touches the curve. Don't let it pass through. So it is right here. I'm seeing a nice line. I'm seeing a nice line. So it stopped on that line right here. And it stopped right here. So it looks like we're going across to 38 based on what I'm seeing. So yes, we're going to get a 38 here. Right there. And we do want to make sure that we have this down the right way. There is our line, 38. All right, so it is exactly 38. So this number right here is 38. Now, the beauty about this question is that we want to understand what they mean when they said less, 28 or less. So we're talking about, if I should employ some shading here so that we could see a little clearer, then less than, so this is my 2.8 marker. Let me mark it. This is the 2.8 marker right there. So if we're going less than, we would have to come to the left of it. So this is the marker, and we're talking about less. So we're talking about these. We're looking at this area here. This is the area you're looking at. And are equal to 28. So we're going right there. We can't go above that line. So we're talking about this rectangular region here that you're looking at. This is the region, that's the people. And this is where we'll have a 38 coming back down, right? Coming back down. So everybody in that region. So the answer for that is 38 students. 38 students. And that will be the answer. All right. All right. Let's move forward now to see what else being asked. All right. So question here says use a cumulative frequency curve on page 18, which is what we're looking at, to complete the frequency table. Now we want to understand that the cumulative frequency table would have produced the cumulative frequency curve. So when you pick up the answers from the curve, that's not the frequency, that's the cumulative frequency. So to be on the safe side, we have, this is my cumulative frequency. I'm just creating a quick little column, like that's a cumulative frequency column. What do we know about the cumulative frequency column is that if I pick up two consecutive cumulative frequency spots, for example, if I pick up a spot here and I pick up a spot here, when I find the difference between the two spots, I will be getting this here. And if I find the difference between these two spots here and here, I'll get here. So we're going to utilize these boundaries here that we have to pick up, because 2, if I look at 2 now, I could tell you that 2 will be giving me 20 there already. And then I need to pick up 4. And then when I subtract whatever I have for 4 from what I have for 2, it's going to give me the spot here. So let's go to pick up 4. What number do I get for 4? Let's come across. Let's come across. You could see 4 is giving me 68 right now. I'm seeing 68 coming out for 4. Talking about 4, we take 4 up. And when we take 4 up, we're getting it right there. So 4 is touching the spot right here and that. So I need to take that across. And we'll see that 68 right here to here. 68. Change my color. So I'm seeing 68 right there. All right. So this is a 68. All right. So then this is 68 right here. So if I subtract this, I'm getting 48. So if I subtract, so 20, you could see the 2 give me 20 here and the 4 give me 68. So if I subtract the 2 here, then 68 minus 20, this spot here is 48. All right. That spot is 48 right there. So let us go up and find what 6 is. Right there. Dig it up. So this line took us up to right there. That looks like about 93. So if I go across here, from here, I'm getting 93. This is 93 right here. That's 93. All right, yeah, so that's a 93. So this is a 93 right here. 93. So this is 93. All right, all right, so it comes across at 93. So then what we're suggesting is that we simply say, all right, if you subtract that the 68 from the 93, you could do it right here. 93, subtract that 68. I'm getting 25. So this part is 25. And then if we should add up everything, we should get like 100. So if you want to double check, 20 plus 48 plus 25 plus 6 plus 1, we get back 100. So we're good. All right. So understanding this, though, that two consecutive cumulative frequency, if you find the difference between two consecutive cumulative frequency values, it is giving you the frequency. And a lot of times the questions, kind of have you giving those ideas. All right, good. So there is our table. And yes, this adds to give a total of 100. So we know that everything here is accurately done. All right, the last question says, a student is chosen at random. Find the probability that the student estimated mass to be greater than 6 grams. So this is a 6, and you follow the 6 go up. All right, we got that. We came across and we got 93 right here. So then we're talking about greater than. So if you're going greater, we're going over in this region here, over in that region, greater than, over. So then you're like greater than that from 93 up to 100. So we're looking at to the right, going over, not underneath, because we're going greater than. All right. So what's that probability? We're talking about 93 to 100 when we do subtract those numbers. So when we do subtract those numbers, what do we get? And remember, we're representing a probability. So the response to that, I got 7. So we're talking about 7 over 100, because it did say as a probability. All right. Some people might write 0.07, or, you could have written 7%. You understand?